Hello.
Hello, sir.
Okay. So we'll discuss complex numbers.
Yes.
Uh, First problem is let A1, A2 till A8 be the vertices of a regular octagon. This regular octagon that lies on a circle of radius 2. Let P be a point on the circle. Let PAI be the distance between P and AI. Here I can go from 1 to 8. If P varies over the circle, we have to find maximum value of the product PA1 multiplied by PA2, so on till PA8. So it's a question based on the roots of unity concept, right?
Yes, sir.
If you remember, x bar n is equal to 1, this equation has n roots, and those roots are at the vertices of a regular n-gon.
Yes, sir.
So vertices of regular n-gon, and the circle had radius 1 here, correct?
Right.
So if I want a circle of radius 2, then x bar n should be 2 bar 8, right? Or x bar 8 should be 2 bar 8, right?
Expert B 2, right?
No, it should be, it cannot be 2, then the radius of the circle will be 2 bar 1 by 8.
Oh, sorry. Right.
Do you understand what I'm saying?
Yes, sir.
X bar n is 1, then the radius of the circle is 1 bar 1 by n, right?
Hmm.
So we need 2 bar 8 to be present, then only you will get it, right?
Yes, sir.
So if this is my equation, 2 bar 8 is like 256, x bar 8 is equal to 256 is my equation, and from here you'll get 8 roots for this. Those roots are going to be my vertices, right?
Yes, sir.
All of them lie on a circle of radius 2, correct?
Right.
So if I write down the roots now, the points of the roots can be easily found. You can say that I'm going to do 256 to the power 1 by 8. So 2 into 1 to the power 1 by 8 I'm doing, right?
Yes, sir.
This 1 to the power 1 by 8 you will do by complex numbers. You will write 1 as e power I 2k pi by n by 8,
8.
right?
Yes, sir.
And k can go from 0 to 7. That will give you the 8 roots, right? When
Yes,
you
sir.
put 0 value, you get the root 2 comma 0.
Yes, sir.
This is the first root, right?
Right.
So this can be also written also like e power alpha is e power I 2 pi by 8, and you keep doing alpha, alpha square until alpha power 7, right? And one of the roots is simply 2, right?
Yes, sir.
Okay. By the way, I should have written 2 alpha square because all of these are powers of 1, right? 2 is always multiplied to everything.
Right. Yes, sir.
So what we can say is that the roots are 2 alpha square, 2 alpha cube till 2 alpha power 7, where alpha is equal to e power I 2 pi over 8,
Huh.
right?
Yes, sir.
So these are the roots. These are our vertices A1, A2 till A8. And now we have to find out uh, the maximum value of the product PA1, PA2, and so on.
Hmm.
Where P is an arbitrary point that can vary on the circle, right?
Yes.
So P can be what kind of a point? P can be 2 e power I theta, right?
Hmm.
Theta can vary from 0 to 2 pi, basically. This is any point on that circle, right?
Yes, sir.
So somehow, if I want to find this distance, I will have to do something like ZP minus ZA1, right?
Yes, sir.
And multiply it with all of them, all such mods. Okay?
Hmm.
This is PA1,
Hmm.
right? So directly, you should not try to do it. What you should think about is these roots had come from the equation z power 8 is equal to 2 power 8, right?
Yes, sir.
So the equation can be rewritten as z power 8 minus 2 power 8 is equal to 0, right?
Right.
And I know the roots of this equation, right?
Yes, sir.
So if I know all the roots, I can write this equation as a product of factors, right?
Right. Yeah.
Do you understand what I'm saying?
Yes, sir.
So basically that gives us a nice condition on Z, and we have an equation like this, right?
Hmm.
Where alpha is given by this thing.
Yes, sir.
So if you have an equation like this, now it will be, now we can say things like z power 8 minus 2 power 8 is equal to z minus 2, z minus 2 alpha, and so on till z minus 2 alpha power 7. And then we can take modulus on both sides, right?
Yes, sir.
We'll get mod of z power 8 minus 2 power 8 is equal to product of the mods, right?
Yes, sir.
So product of all of these mods you're getting. Now is the point to, you can put p coordinate into it, right?
Hmm.
But ultimately you need a maximum value for this product, max value,
Yes, sir.
right? So the product's max value would be the maximum value of this after you have put the p coordinate into it. Here z can be any point p now, right?
Yes, sir.
So we will say mod of z power 8 minus 2 power 8 is less than or equal to, by triangle inequality, mod of z power 8 plus mod of 2 power 8, right?
Hmm. Yes, sir.
So this is less than equal to mod of z to the power 8 plus 2 power 8, right?
Right.
And for any point on that circle, mod of z will be what? 2.
Two.
So this is less than equal to 2 power 8 plus 2 power 8, which is equal to 2 power 9, right?
Right.
So basically, we are getting that this quantity is less than or equal to 2 power 9, right?
Yes, sir.
So we have proved that the product is less than or equal to 2 power 9 for any z.
Right. Yes, sir.
So the maximum distance would be 2 power 9. That will be the answer, 512. So this is a conceptual question because this is a standard transformation. Okay.
Hmm.
Any equation in complex numbers, whatever the equation is, you can always write it in terms of its roots, right? Like this.
Yes, sir.
So here the equation you need to know, it is this equation. And we wrote it as z minus 2, z minus 2 alpha, and so on. Why is that form useful? Because taking mod on that gives us the product of PA1, PA2.
Hmm.
And then that means that that is equal to mod of this.
Yes,
And
sir.
then we are applying triangle inequality to this, which is less than equal to mod of z power 8 plus 2 power 8, which is equal to 2 power 9. Is it clear?
Yes, sir.
You need to be able to find all the roots properly in such nth roots of unity type of questions, and also know this standard technique.
Yes, sir.
Okay. The next problem is Let Z be a complex number which satisfies mod of Z cube plus 2Z square plus 4Z conjugate minus 8 is equal to 0. Imaginary part of Z is not equal to 0. That is given. Now you have to do a match the following. Mod of Z square is equal to mod of Z minus Z conjugate whole square is equal to mod of Z square plus mod of Z plus Z conjugate whole square, and D mod of Z plus 1 whole square. And here the options are 12, 4, 8, 10, 7. You have to select the correct option. Try it out. I'll be back in 2 minutes.
Okay, sir.
Are you getting something?
Uh, Not yet.
This equation, you can try to manipulate it by doing some operations, like you can take conjugate on it, right?
Yes, sir.
So this is a real number, so its conjugate will be same.
Same.
This will be 2z conjugate square plus 4z minus 8 is 0. Now we can subtract the equation and get a simpler equation, right?
Right.
This and this will get cancelled. This and this will get cancelled. You have 2 times z square minus z conjugate square plus 4 times z conjugate minus z is equal to 0, right? So z minus z conjugate can be taken common. 2z minus z conjugate common. You have z plus z conjugate here, and you have a minus 2 here, right?
Right.
So now this is a simpler equation because now you can say either this is 0 or this is 0, right?
Hmm.
Z cannot be equal to z conjugate because then it will be real.
Yes, sir.
This is not allowed, right?
Right.
So basically you get z plus z conjugate should be 2,
Hmm.
correct?
Right.
So if z is x plus iy, basically 2x is equal to 2, so x is 1, right?
Yes, sir.
So z will be something like 1 plus iy now.
Right.
And now it is possible to use this information to try to solve the original equation, right?
Hmm.
Because now you have only one variable,
Yes, sir.
and you will say that some complex number here is equal to 0, right?
Yes, sir.
So the operation that helps solve it is taking conjugate and getting a similar equation and then subtracting,
Yes, sir.
right? So now try to solve it from here. Are you getting something?
Sir, just a minute.
So this type of an equation is coming. If we just focus on the real parts of it, that should be zero, right?
Yes, sir.
So we are getting 1 plus y square to the power 3 by 2 plus 2 into 1 minus y square plus 4 minus 8, so is equal to 4, right?
Yes. So
You can 1 plus y square is here and there is a root 1 plus y square. And okay, so okay, you can take this to the other side. I think.
yeah.
You get 1 plus y square to the power 3 by 2 is equal to 4 minus 2. So 2 plus 2,
2 plus.
uh, this is coming.
Yes, sir.
So this can be cancelled and you have power half. So 1 plus y square is coming out to be 4. So
Yes.
which is actually mod of z square, right?
Hmm. So y is equal to root 3.
Y is equal to plus minus root 3, right? Or y square is equal to 3 for sure. So here it is 4. And here if you see this part is 4. And this part we already know z plus z conjugate is 2. So this is
2.
4. So this is 8.
Yes.
Now we can find everything. Y we know. So there is no issue here. Z minus z conjugate will be 2iy.
2y.
So 4y square here.
Yes, sir.
12 and everything we can find this.
Hmm.
So main idea here is taking conjugate, subtracting, getting this condition. Once you get this condition, using x plus yy to find basically that only one variable is left. Then you put that back in the original equation and get an equation from here.
Yes, sir.
Okay. Uh, let z be a complex number with non-zero imaginary part if 2 plus 3z plus 4z square divided by 2 minus 3z plus 4z square is real. Find mod z square. Second question is in the set of complex numbers, find the number of distinct roots of the equation z conjugate minus z square is equal to I z conjugate plus z square. Try these two.
Uh, Sir, the first one is at 1 by 2.
Hmm. Right, 1 by 2 is correct. There's nothing major here, just standard stuff, right?
Yes, sir.
You can simplify it a little bit, but like you can make it such that this part is matching the denominator. You
Yes,
can
sir.
like this and plus 6z.
Hmm.
And then this becomes 1 plus 6z by denominator. And this is real means this part is real. You can divide by z also. 6 by 2 by z plus 4z minus 3 is real, right?
Yes, sir.
So basically this part has to be real then.
Right.
2 by z plus 4z is real. And then it is simple. You just say that this is equal to its conjugate.
Yes, sir.
Okay. Try the next one. Then write z square as z into z conjugate.
Uh, Sir, isn't that mod z square?
I'm making a mistake. Right. You can't write that. So maybe we should take more, but that will not help. Okay, so then we do conjugates then. These are two different equations. Uh, we have to think whether we should add or subtract. You can add it and see z plus z conjugate minus z square plus z conjugate square is equal to I common z conjugate plus z square minus z conjugate square. So you're getting z conjugate minus z minus z conjugate square minus z square. So z conjugate minus z common 1 minus z conjugate plus z multiplied by I. This thing is equal to this thing.
Right.
But that is not helping us simplify very easily. Okay, so then maybe it is easiest to just simplify this equation directly. Z conjugate into 1 minus I is equal to z square 1 plus. Okay, this was what we should have done. Can you see this?
Right.
Right?
Yes, sir.
It is just a simple simplification. Now we can take mod because it's in a product form.
Yes, sir.
We'll say mod of z conjugate. Mod of this is root 2
Root
is mod of z square into root 2, right?
yes, sir.
So you're getting mod of z conjugate is equal to mod of z square. This is same as mod of z. So mod of z can be 0 or 1.
Yes,
Mod
sir.
of z should not be 0 because then the complex number is 0, right?
Yeah.
So basically one root is 0.
Yes, sir.
The other root will come when you do mod z is 1. If mod z is 1, then z conjugate is 1 by z, right? So now we can, instead of z conjugate, we'll put 1 by z there. 1 by z minus z square is equal to I 1 by z plus z square, right?
Yes.
Or we could have done it here in this equation, it is better.
Um,
1 by z, and we'll get 1 minus I by 1 plus I is equal to z cube.
Z cube.
Multiply by 1 minus I, you get 1 minus I square. So 1 plus I square minus 2I. So minus 2I by 1 minus I square,
Uh,
so 2, right?
yes, sir.
So z cube is equal to minus I, and now we get three roots of this now, right?
Yes, sir.
So we can say z is equal to z cube is equal to minus I is e to the power minus I will be e power I minus pi by 2, right?
Right.
Correct? Yeah. So we'll say z is equal to e power I minus pi by 2 plus 2k pi whole divided by 3, where k can be 0, 1, 2. Right? Do you understand what I'm saying?
Yes, sir.
When you put 0, you'll get one answer. When you put 1, you'll get another. And when you put 2, you'll get another, right?
Hmm.
So those will be 3 answers. And there is one answer from here. So the total answer is 4. So basically, this simplification had to be done like this. Then it is easy.
Yes.
Simplification made it like this. And then we could take mod on both sides because it's in the product form. So modulus will be useful.
Ah,
We can't take mod directly here. We can't do anything with it, right?
yes, sir.
Once you got mod z is 0 or 1, the question is easy after that.
Hmm.
Remember that we are using the property mod z square is z z conjugate to get, if mod z was 1, you get z conjugate is equal to 1 by z.
Yes, sir.
Ultimately, the question is asking us for solutions in the set of complex numbers. That doesn't mean we have to get only imaginary numbers. It means real numbers also.
Yes, sir.
Because the set of real numbers is part of the set of complex.
Hmm.
Okay. Uh, Fine. The next one is for any complex number w is equal to c plus id. Let argument of w be between minus pi to pi. Alpha and beta belong to real such that for all complex numbers z is equal to x plus iy, satisfying argument of z plus alpha by z plus beta is equal to pi by 4. The ordered pair x comma y lies on the circle x square plus y square plus 5x minus 3y plus 4 equals 0. You have to select the true statements. Alpha is minus 1, alpha beta is 4, alpha beta is minus 4, and beta is equal to 4. So understand the question saying for any complex number w whose argument is between minus pi and pi, alpha beta are real numbers such that for all complex numbers z which satisfy this condition, the ordered pair x comma y lies on the circle. Basically, z lies on this circle. Right?
Yes.
Alpha beta are real such that z lies on the circle and this condition is also true.
Yes, sir.
You have to find out the alpha beta structure. You have to realize the meaning of argument of this thing. It can be written as this, right?
Yes.
If you know your angles and all, how to handle angles in complex numbers, usually it is like this. Uh, Z is here, and this is some complex number Z1, and this is some complex number Z2. And this argument is argument of, you should write Z2 minus Z by Z1 minus Z, right?
Yes, sir.
This is how angles are defined in complex numbers.
Yes, sir.
So here we have a common Z everywhere. So that could take the place of my vertex, right? We can reverse it and say it is minus alpha, or it is multiply by minus 1 both up and down. So you are getting, this is z plus, so minus alpha minus z, right?
Hmm.
Instead of z minus alpha minus z,
Yes.
and you get a minus beta minus z also, right?
Yeah.
So we are saying this is my z1 or z2 and this is my z1, right?
Yeah.
Do you understand what I'm saying?
Yes.
So basically, this is defining the angle z2 is minus alpha and z1 is minus beta, right?
Right.
And it is saying that the angle between this and this is always pi by 4, right?
Huh.
Correct, no?
Yes, sir.
So what you should realize from here, the angle is made at the point z, right? And alpha beta will be some fixed points.
Yes.
Alpha beta are real numbers, so there will be some points on the number line, right?
Yes, sir.
So then it is saying that the angle is always, even though z can be varying, the angle is always pi by 4, right?
Right.
And z lies on the circle, right?
Yeah.
So you should realize that this is like the arc of a circle, no?
Right.
Then only you can get something like this, no?
Yes, sir.
As the point varies on the arc, the angles are fixed.
Yes, sir.
These are real points. And z is lying on the circle, right? So
Right.
that means that the angle at the center of the circle would be 90, right?
Um,
Center of the circle is clearly known.
hmm.
It is minus 5 by 2 and 3 by 2, right?
Yes, sir.
Minus 5 by 2 and 3 by 2, and radius of the circle would be 25 by 4 plus 9 by 4 g square plus f square minus 4, right?
Right.
So this is 16 by 4. So 9 by 4 plus 9 by 4. So that would be 9 by 2. So 3 by root 2.
Yes.
Correct?
Yeah.
So we know that there will be a right angle triangle here somehow, right?
Hmm.
And this is R and R. Correct?
Yes, sir.
So now we will know the distance here between these 2 points. Correct?
Right.
Do you understand what I'm saying?
Yes, sir.
So basically, what do you have to find? We have to find the alpha beta product, you know. This point is minus alpha comma 0 because it's real. Y coordinates are all 0, right? And
Right.
this point is minus 5 by 2 comma 3 by 2, right?
Yes.
And we know angle between them is 90. So we can use slope and all now, right?
Yeah.
We can use Pythagoras theorem also. We can use slope also to get alpha and beta.
Hmm.
You will say 3 by 2 minus 0 by minus 5 by 2 minus minus. So alpha minus 5 by 2
Huh.
multiplied by 3 by 2 minus 0 by minus 5 by 2. So beta minus 5 by 2 is equal to minus 1.
Yes, sir.
So from here, we get one information. Then we can use Pythagoras theorem also.
Hmm.
We can say r square plus r square is equal to this distance square, which is mod of alpha minus beta square, right?
Yes, sir.
Is equal to 2r square. So 2 times 9 by 2, correct?
Yes, sir.
Mod of alpha minus beta is 3 or minus is 3,
Hmm.
correct?
Hmm.
So from here we can say alpha is equal to either beta plus 3 or it is alpha is equal to beta minus 3. Now you put that in this to get alpha and beta.
Yes, Yes.
You'll use this condition once and you'll use the other condition again.
Hmm.
Is it clear what we are doing?
Yes, sir.
Because the point lies on the circle, and because of that angle stuff, the angle was constant even if z was changing. We know it's like the angle in an arc
Yes, sir.
or the angle subtended by a chord.
Right.
That angle was 45, so the double of that is 90 at the center. We know the center. After that, it's a coordinate geometry problem. Can we
Yes.
find alpha, beta, or not?
Hmm.
Is it clear?
Yes, sir.
Do a little bit of revision of complex numbers. We'll do another class tomorrow. We'll keep it short only for now. We'll do another class and we'll try to do more problems of complex.
Okay, sir.
Do some revision of the chapter. See the theory in your Allen module or in your textbooks that you have. Make sure that you know the basic geometrical properties. Those are the ones that are likely to come.
Yes.
Okay, fine. That's all for now.
Thank you, sir.